Alrighty, happy section 7.5. Whenever I made this presentation last time, it happened to be Tuesday, I think. And it reminded me of a great time back in college where every Tuesday they would have tacos in the lunchroom. And I would probably eat 5 or 6 of them. Taco Tuesday, it was great. But anyway, we're in section 7.5, and we're going to deal with a couple of theorems especially. And our goal is I can use the side splitter, awesome name, side splitter theorem, and the triangle angle bisector theorem to solve problems. So let's see what those are and how we can use them. So we're going to start off with the side splitter theorem. All right. When two or more parallel lines intersect other lines, proportional segments are formed. Okay? Proportional segments are formed. Meaning, so if we look at this theorem, it says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportional. And if we have this line dividing is parallel to xy, RS is parallel to xy, then it divides it up so that QR, the distance of QR to the distance of RX would be equal, that ratio would be equal to QS to SY. So those ratios are equal. That makes up a proportion. So if we look at an example for this one right here, we have a parallel line to this one side. So that makes these sides proportional. So the ratio of 12 to 3 would be the same as the ratio of 2x minus 3 to x minus 5. So they're making similar triangles. So this larger triangle is going to be the same as this smaller triangle, or and so forth. So then we can solve the proportion using our cross products. So 12 times x minus 5 would be equal to 3 times 2x minus 3. And we work it out, we do a little distributing, we get 12x minus 5 equals 6x minus 9. Subtract 6x from both sides, do a little of that algebra, add 5 to both sides, do a little of that algebra. You're left with 6x on one side and negative 4 on the other, it looks like. Divide both sides by 6, divide both sides by 6, you end up with x is equal to negative 2/3. Actually, looking back, I made a mistake. I forgot to distribute over here. Common mistake. Hopefully you noticed it, but that is a common mistake that I see. This should have been 60. So you should add 60 to both sides. So this actually would not have been negative 4. It would have been negative 9 plus 60 would be 51. So it still doesn't work out like we'd like it to, but x would be equal to negative 51 over 6. Please, if I made a mistake, let me know next time you see me. We're going to move on. The proportion on number 2, same idea. 12 minus x, that ratio to x plus 3 would be equal to 6 over 4. So cross multiplying, I've got 24 minus 4x equals 6x plus 18. What I'm going to do is add 4x to both sides and subtract 18 from both sides. I get 6 equals 10x. Divide both sides by 10. You get x is equal to 6/10 or 3/5 would be reduced. Alright, so looking back at that formula, we've got the two sides are, so if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. All right? All right, if you'd like to know how to prove that the theorem, it's a theorem, you can look in your textbook. There's a proof of that. All right, we're going to go on to a corollary that comes from that. This corollary states that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if we have that line A, B, and C are all parallel to each other, then we can say that AB, the ratio AB, well, we're going to AB to BC would be equal to WX to XY. This is a really bad Y. Alright, so let's do that. So we look at our example over to the right. CD, right here, is to what as AC? So we have AC is to AI. So I think CD is going to have to be IJ. Alright, I'd like to do number 4. So number 4 says FG is to EF as CD is to what? So let's go like this. FG is to EF as CD is to be BC. Alright, then third one. JG is to GD. JG is to GD as nope, I said that wrong. JG is to what as GD is to AD. So GD is to AD. Now, I don't know that this one would work, just because of what parallel lines we have. This does not come straight from our thing. But if we want to look at this, then the corresponding part would be AJ right here. All right. All right. So a little bit of algebra. Use algebra to solve for x. So we have 20. We have our parallel line. So 20 over 8 would be congruent to 35 over x. Then you can do your cross multiplication and solve it. You get 20x equals 8 times 35. 8 times 35 is 280. And divide that by 20. X is going to be equal to 14. All right, one more. Solving for x. Ooh, we've got a lot of stuff here. So we can look at it this way. We have those are our parallel lines. So if we're splitting this up, we're going to look at this and this compared to those other two. So x minus 5 over x minus 2 would be equal to x minus 1 and 2x minus 1. And when you do some cross multiplying, this is going to turn out interesting because you're going to have x minus 5 times 2x minus 1 equals x minus 2 times x minus 1. So when we do our FOIL method, first outside, inside, last, this side we'd have 2x squared minus 1x minus 10x plus 5 equals x squared minus 2x minus 1x plus 2. So really we have, and we can combine like terms, but yeah, that's what we're gonna do. So we have, this is gonna actually be negative 11x. This is gonna be negative 3x. So what we're gonna do here is we are going to try to get some things on the same side. So let's get rid of this 1x squared and get rid of it. Let's do that over here. So we're left with 1x squared over here. Because we want them all on the same side to solve the quadratic. So we're going to add 3x over here, and add 3x over here. So you have minus 8x. Then we're going to minus 2 over here. Minus 2 over here. And minus 3. So we have nothing left over there. That's all gone. And there's our quadratic. So look at it as this is, you can use the quadratic formula. You can use a couple different methods. You've learned a couple different methods, but right now just look for target numbers. And actually, you know what? I made a mistake, so it's supposed to be plus 3. But we're gonna stop in this. You can't tell two numbers that would multiply to equal 3 and um, add to equal -8 right now. It's gonna be weird decimals. So we're gonna stop it right there, and you can actually, you can use the quadratic formula if you'd like, which again is x would be equal to b squared, or minus b, oh, come on, minus b plus or minus the square root of b squared minus 4ac all over 2a, where a would be the number in front of the x squared, b would be the number in front of the x, and c would be the number at the end. So we plug in 1, -8, and 3. You are going to get decimals though, and I'll tell you right now, x is going to be equal to approximately, I checked it on here, let's see, if my computer works, 7.6 and 0.39, not pretty numbers. Alright, so moving on, we have one more theorem, and it's the triangle angle bisector theorem. So here it says the blank of an angle of a triangle divides the opposite side into segments. So the bisector of an angle of a triangle divides the opposite side into two segments with lengths proportional to the sides of the triangle that form that angle. So we're bringing it back to triangles. If a ray bisects, so the actual theorem states, if a ray bisects an angle of a triangle, then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. So if we look at it here, so AD is bisecting angle CAB. Then we know that CD is to DB. That would be equal to CA over AB, or BA. Alright? So if we look at this triangle right here, let's use that thing. So we have a line that's an angle bisector. So we know one is x, and this would be 18 minus x. But CD, we'll use 18 minus x is to x as 15 is to 10. And you can solve your proportion. So on one side we have 180, we cross multiply, 180 minus 10x equals 15x. We add 10x to both sides. We have 180 equals 25x. And x then, if you solve that, 180 divided by 25, it's going to be a decimal, I believe, but a little bit over 7. 7.2. Alright. I have two more examples here. These are both more challenging ones, and I encourage you to try them on your own. But I'm going to start you off by looking at the graph a little bit. But number 9 we'll just look at. It says in triangle LMN, PR divides NL and MN proportionally. So we're using that triangle angle bisector theorem. If the vertices are 820, we're going to use this nice handy dandy graph here. And I didn't give a good enough graph. 820 and 1116. So that's going to be something like this. 820. That's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way up here somewhere. 820, that's going to be way ish, 11/16 way over here, and somewhere over here ish. I know I'm just estimating it'd be actually farther up. And R is 3 1/8. So it's saying that the proportion of LP to PN, hold on. So my little drawing here might help visualize it. It's not accurate at all because my coordinate plane was chosen poorly. But if we have points N up in the top here, which would be somewhere up there, L and or P and R is what we're given. The P and R is what's dividing the MN and the NL. So I drew it like this. So I just visualized it. It's not perfect, but the M would be somewhere down here and the L would be over here. Now remember that these two would have to be parallel for them to be proportional. And also it says that LP is 2, LP to PN would be 2, proportion would be 2 over 1. So this distance right here, this PL has to be twice the distance of that NP. Right? So I'm going to leave it at that. If you can figure out number 9 or number 10 on your own, actually move this. Number 10 is similar. I'll give you a piece of candy, one or the other. All right, good luck with those, and we'll see you next time.